Okay, yeah, welcome to Integrated Results in Mathematics. So, most of the students have we received sort of requests from most of the students to conduct this part, right? Okay, so I have decided to run up this part with statistics, right? So here, I don't want to discuss too much. Uh, so let's go for the practical now, right? So I have decided to break them into two parts called the theoretical part and the practical part, right? So let me introduce you very briefly what about this practical part and what about the design, right? Okay, so sometimes once we are handling data, we need to use any type of language here. Here I'm going to use RStudio. This is a language based on Python, right? Okay, this is developed through Python. So first of all, we need to take a rough idea about this language, how it would look like. Okay, this is the interface. Here I'm not gonna talk about how to install these RStudio, something like that, right? Okay, so at once let's go for the theoretical part. Sorry, in the theoretical part I'll be discussing here the theoretical part very briefly, and then I'm gonna explain you how to do the coding part using RStudio, right? Okay, so then so in the theoretical part, most of the students they have these type of questions. They don't know what about the contrast between these probability functions. There are majorly two types of probability functions named yeah, probability density function and probability mass function, right? Okay, so really, what about the contrast between these two functions? Probability mass function stands for discrete data. So for an example, let me show you. You can see this image now. Let me maximize it. So here there is a histogram. Really, this is not a yeah. Okay, you can see this the height of this bar will denote what this is the frequency column for each of these classes. Here you will have these classes. This is the interval. This is a class boundary. There is a pretty much close. We're gonna make it a very tiny part because once we're gonna talk about the continuous data, we can let delta x goes to 0. Here delta x is a finite value now, right? So class frequency will be denoted by little n1. So the probability which is related to the particular scenario, particular interval, can be written. For example, let's talk about the first class interval L1. So the probability can be written as little n1 upon upper n, because all the scenarios can be happening will be given by upper n. So the ratio between that likelihood. So then so the probability which can be assigned for the particular class, how we can say it is given by the area of each of these bar, right? So the corresponding bar I will be giving you the probability, corresponding probabilities, right? Okay, so then we can have an idea that each of these bars mean is rectangles, right? Rectangles means you can find out the height of each of these bar. For example, let's talk about the first column, first class, little n1 upon upper n is the probability. It is divided by delta x, which is known as the width of that corresponding bar, so the class width, right? Okay, so then it will be giving you the height of this bar. So this is what this is the probability mass for this particular moment. This is the probability mass, right? Okay, so then you can understand that this is not the frequency, this is not the probability, this is the probability mass. Probability mass was split out against classes or the data, right? Okay, so that is what I mean by the probability mass function, right? Okay, then you can make it very tiny slides. We're gonna make an approximation here. So then once we let delta x goes to 0, let me check whether it is being recorded or not. Yeah, okay. Luckily it's being. Right, okay. So then it becomes very smooth. Very smooth. So in final we are gonna make it very tiny slice. So you can have a very smooth curve. There is a curvature now. Right, okay. So then we can say there is a what here. Okay, with your calculus knowledge you can use your calculus knowledge. Height of this bar, height of each of these bar will be given by the area of the bar is divided by the class width or the delta x, right? So this is going to be approximately, this is going to be equal to the probability xi minus delta x upon t, which is the lower boundary. Upper x is existing between these two boundaries. Upper boundary is known as xi plus delta x2. So this is the probability. Probability is the area of this bar of these bars divided by the corresponding class with delta x. So we can let delta x goes to 0, then we can say this is going to be equal to the height of the curve. So once delta x approaches to 0, it is known as probability density function, because once each of these class bits approach to 0, it approaches to 0, we can say there is no more discrete data, there is just there are just continuous data set, right? Okay, so so the height of these curves will be giving you what? Probability density, and the probability of the frequency. So most of the students are confused and really they are misunderstanding about this. This is not the frequency, the probability, this is the probability density, right? Okay, so the function is known as probability density function. So once you're going to integrate this probability density function, you can see this is pretty much easy to show. In my theoretical part, I'll be explaining everything again, because really I'm going to concat these two videos. This is for application part, right? Okay, this will not be very difficult or very hard to do. I'm pretty sure that this will be super cool enough to understand, right? Okay, so then this is the probability density function, right? This is the probability density function. Once you're going to integrate it means this delta x stands for both this denominator and the numerator, so then you can cross it. Once you cross it, this is what on the left hand side there's the probability density function. So once you get the reciprocal, you can say there is the integration, or the on your right hand side here I'm pointing over, right? This is the first derivative. So once you get the reciprocal, sorry, once you're gonna go for the reverse process of this derivative, you will meet integration. So that's what they have done, right? Okay, hope you could have an idea roughly. So really that is enough. So you can see that they have shown you sort of data here, right? Okay, here is the data set. What is the data? There's it here. You are given writing times of use the writing times of 40 randomly selected ballpoint pens of a certain brand. Let upper x be the writing time of a random selected pin suggest a suitable model for the appropriate density function of x, right? Okay. There may be a probability density function. So with this data, you are given only sort of data. Here it means that maybe a sample, right? Okay. So how we can use this sample? Let me show you how to work with this interface. I'm using RStudio. Then you can click on, okay, click on file. Here, let me here. You need to install it and click on file and new file. Then you can select R Markdown. Then you have this type of window. Then you can make a title there, right? Right. Okay. Then you can have this type of interface. So this is not needed. I can clean everything and click on insert. If you're gonna use R, you can use this R, right? Okay. Then it means that there is nothing else. It really makes very, very convenient to deal with. That's why I'm gonna use it, right? Okay. So I have done sort of things for you guys, right here. This is the dataset what I have inserted in your here. The same dataset was inserted here in that book, right? 31.7, 29.0, 31.0, like that, right? Okay. So then each of these every data was inserted here. So once I'm gonna make a new dataset inside of this RStudio Markdown, you can type. I have named it as X, right? You can make something else. It doesn't matter, right? Okay. Then there is arrow less than and use this code. So then you need to start it with C, and inside of this parenthesis you need to assign your dataset. This is the code which stands for this inserting a new dataset, right? So then I needed to find out the histogram. I needed to interpret this histogram. So the code is hist, okay, hist inside of this parenthesis. You can see that once I'm typing here, he'll be given some clues there, right? So X is our new dataset. That's what I want to make the histogram, right? Okay, and then I need a box plot and the mean and the standard deviation of this dataset, right? Okay, then I can run it here on your right hand side, run current chunk, right? And you can see here. This is pretty nice, easy to do. You also can check whether it works or not. If there is something issue, you can ask me here. Okay, this is the histogram. You can see that this is really very much similar to the given one. And also, I hope to talk about this is not the sole way we can interpret this histogram. There are sort of ways, and also there are sort of libraries we can use here. Even we can manage these class widths. This is automatically fixed, right? Even we can handle each of these class widths here, right? Just like ggplot. Well, we can use ggplot, and you will be taught how to handle it, right? Okay. So this will be the box plot, and this is what the mean and the standard deviation, right? Okay. Uh, Probably let's have a glance on the next one also, right? Okay. Really, this is just an introduction. This will be an introduction for you guys. So I'll be explaining you all of these theoretical parts nicely. And also, if you are having any doubt, you can ask us. Right. So this is the next dataset I have chosen, Suppose there has an accident today. There has been an accident today. Using your model, calculate the probability that, yeah, okay, 30 days, yeah, you're given here, right? So I have, I need this interpretation only. Let me show you. This is really, it follows an exponential module. In this probability, there are sort of models, just like binomial models, binomial probability distributions, maybe sometimes negative or positive binomial probability distributions, maybe a normal distribution, which is known by bell curves. So we started here, and also we have gamma distributions, F distribution, and also T distribution. There are a bunch of distributions. So this is what it follows of the exponential model, right? Okay, so that is what the usage, that is what the profit of interpreting these type of histograms. First of all, we need to have an idea about that. Otherwise, we are not able to guess what about the shape of this distribution. Why will be this distribution? What's the distribution this will follow? What's the distribution this is pretty much close to? Right, okay. So that is why how we can interpret them. That's the importance of these histograms and the and using this software, right? And also the next data set was given. Okay, so I'm going to stop it by here for now. In the next case, I have eliminated here. Let me show you what about this box plot. I'll be explaining you very briefly here, but I hope to explain you everything. There you can see here in this box plot. Once you are paying attention on this box plot, you can see there are three outliers. So we can um, remove them manually by recognizing, and also there are sort of ways to um, eliminate it at once. Once you're giving some commands, you can eliminate these outliers at once with coding part, right? But here in this second case, I have eliminated them using a manual part. You can see it here, right? So I have eliminated them. There is no any outliers. There is a skewed data set, and so there is a nice exponential distribution model, right? Okay. So then, for now, I'm going to stop it by here, and hope you can get these two videos. Then hope you can have a brilliant idea about each of these things. If you have any doubts so far related to these things, yes, you can put a comment, right? And also you can contact us through our website. I hope to give you an introduction video about my website, how you're gonna, how you can work with us, how you can join with us, and also you are given sort of facilities there. You can request them, right? Okay. I'm Sabumal Seno, the Rogis of Sanksagara.